Hello and welcome to our introduction of the brand new MotorDoc EMPOWER motor current signature analyzer. The first module we have out is for induction motors. The rest will start coming out in 2025. This one, as a matter of fact, the example I will show is on a motor, on a VFD, small motor. But the whole idea is that we're trying to democratize, I guess is the new word, current signature analysis and electrical signature analysis. So this one is a low-cost introduction to the technology. It's going to be very accurate. It is very accurate. We've been testing it in the field already. It will give you an accuracy down to 0.01 hertz across the entire spectrum. Right now, this will be the only one that does that. And it does a lot of other things. But off of one phase, I'm not going to see things like loose connections, and I'm not going to see power quality issues coming in. What it will tell me is it's going to use the motor as a vibration transducer to look at bearings, windings, alignment, soft foot, static and dynamic eccentricity, belts and shivs, pulleys, pumps, gearboxes, you name it. Those are all built in. I'll show you that as we go through real quick. Originally, this was going to come out next Tuesday on October 8th. We were going to announce it as a beta that would start shipping on November 1st. Well, surprise, surprise, the team and I got together and we discovered that we're done. So other than some cleaning up and some error handling stuff and a few other things that'll be done long before November 1st, we're going to launch this as a final product. However, I promised people that we're going to do a special price as a beta starting November 1st until December 31st. Well, we're going to keep that in play. So the first people to purchase over the next next several months will get it at the discounted price. We're talking about a system that's well under $10K when it's at its full list price. So contact us for a quote. It's very portable. I'm of course going to have thrown a picture up in here. I don't have my face on here because my system lags a lot when I'm running a lot of things. I have a lot of things running in the background. So quick tour. So the first screen here, this is going to be the date and time that the data was collected when I open it up. New analysis means that's for the data collection portion. Right now it's preset 120 seconds to give me 0.01 hertz resolution. Open motor allows me to open the nameplate of the machine. That data goes in here. So I put in my motor nameplate information here. Anything having to do with coupling. So if I'm doing a motor sitting unloaded on the shop floor, matter of fact, a lot of the testing we're doing in here to make sure we have the accuracy and the resolution we want is on test motors in our lab that are small, but completely unloaded. So we're talking about running almost synchronous speed. We're still able to discern the defects. I've already tested in the field on loaded motors that are 2300 volt, and I've done some 4160. It works great. I can also select direct drive, meaning no coupling, whether it's a belted application, gearbox, pump, or fan. As I select each thing, it'll adjust how each other component is calculated. So if I select a belted application going into a pump or fan, then the speeds that are applied against these values here will be based upon the ratio and slip of that belted application, that kind of thing. So a lot of stuff that I've built into a lot of work over the years. Now here's what's kind of fun about this project. It's not AI. It's not ML. But everybody likes to use AI and ML. So we had a challenge brought to us about a year ago. And somebody said, do you think you could create a product from start to finish using ChatGPT and all of these variations? And I said, well, what language can I do it in? And the challenge came down to Python. And This was just a, handshake type challenge. And I said, sure, why not? I know Python, I know this. And the idea was to really put technology to the test. And we've been sticking with all this stuff as it advances. The problem I had is Python is not a fast enough language to take in data that's required if it's in CSVs and basically the type of data that's handled by a lot of things. So come around summer, discovered that there was a hardware available that could take in data from a clamp-on type current transformer, anything that puts out millivolt per amp, and convert it over to a sound file. Well, Python is fantastic with sound. So 5 weeks ago, we said, yep, we're going to start creating. We got our hands on the hardware, and we said, we're going to create this from scratch. So what you're seeing here was developed in collaboration with our software people, our people that are knowledgeable about, actually our software people are also our people that are knowledgeable about the technology. So we learned a lot of things about the use of artificial intelligence and ML, especially generative AI, in the development of products and the development of software. And that is, it's not going to replace anybody's job anytime soon unless they're intermediate or basic users. Now, all my people are advanced, so we've got advanced programmers, and we required that level of knowledge in order to identify whenever it steered us wrong. We had experts in the field because we did not trust generative AI to do our formulas for us. We allowed it to set out the framework. We allowed it to set out this background. We allowed it to do other things and set up the order and keep it lean and mean so we're at under 10,000 lines of code. That's the technical side of this. We've got some additional error handling we're putting in there. We had it test certain things so that we could make sure the software is robust. We did not verify it in a lab. We've been in the field verifying it. So this is a field verifiable, and we've compared it against other vibration equipment, electrical signature analysis equipment, et cetera, et cetera. We've been running everything side by side. Now, again, as I said, this is not a replacement for technology like Empath. It will provide you something very portable and very capable. And then if you want the advanced analysis capabilities, then you talk to us about that. Same type of thing. It does a lot of the analysis automatically. In the meantime, we've had a lot of people that approached us, and data collection, even continuous monitoring with electrical signature analysis, even vibration and ultrasound was just out of their range. So this system, again, if I didn't mention it earlier, is under 10K, well under 10K, even in its final form. So let's go ahead, and in a couple of minutes, just because I can't run this in the background because it'll conflict with my microphone, new analysis would start a new analysis that would allow me to collect data. It takes 2 minutes. I can see the waveforms and everything else. I'll show that another time. Open motor allows me to open an existing nameplate data. New motor sets everything to default and allows me to set up a new motor. Open analysis allows me to open something that I've already collected data on. About just shows you an about screen. And then exit takes you out of the software. So let's go ahead and let's open an existing analysis. This is a little 3/4 horsepower from the lab. These are all the latest and greatest, my playing with the stuff. Everything, I mean, the nameplates are all in JSON. For those who know internet stuff, that means it's only going to require me and the team just a little bit to convert this over if we ever decide to make this web capable. So as you can see, it's running all of the stuff necessary to make sure, and it's doing some error checking on the data. You won't see that, well, the quote-unquote beta version, you'll see all this. And yeah, we're a 60 hertz area, and we're running it on a VFD at 50 hertz. So I'll show you what that looks like here in a second. Okay, and we're having it add all the harmonic markers. So here we go. There's our data. This is when I took it the other day. This is my peak-to-peak RMS current. I need it this way for a specific reason in the system. This allows me all my manipulation of each individual portion. So if I'm curious about something, I can just zoom in, and then if I need to move it around, if I've made a mistake or something like that, I can move it around. I can follow it along, whatever I want. I can step back, I can do this, or I can even save this as a figure, as a PNG. Same thing here, and you'll also notice the X and Y. So X is the frequency, Y is the point where I have the pointer. So if I come up here and I want to know what this peak is, that's at 1799 hertz and 29.4 dB down, so minus 29.4. So I can also just as easily zoom in. You'll notice this looks an awful lot like this. So we just do a snapshot here at 200 hertz. And from here, I can do the same thing. I can move it around. I can even dig all the way down and see what this individual point looks like. So all of that is there, step backwards and home, and then also the watts associated with any potential losses. So if I want to know any losses, so that right there, that high peak, that is basically line frequency. I can come in here and see what certain defects are. So this is my running speed. This is a little bit of vibration, and I am down at a certain level here, about about 0.2 watts. So not a lot. I mean, there usually is not a lot, and this is an estimation, by the way. I'm assuming a certain incoming voltage and everything else. So in order to calculate the watts, this is going to do something. Motor nameplate, I already showed all that stuff. So let's come here, and I don't have RPM yet. I don't have any types of faults. Well, I do have in the motor nameplate, I put in bearing information, rotor bars and stator slots, that it's kilowatt value. I put it in as a 0.5 horsepower. Let's change, I'm sorry, that should be a 0.7 kilowatt. So let's go ahead and save that. I'm just updating everything, allowing me to overwrite it. So there we go. So now when I come back here, I hit auto analyze. You can see lots of things happening in the background, and it's doing all the calculations. Basically, you don't have to worry about what settings you need, Fmax, any of that stuff. And it's going to calculate out where all my markers are going to assist me in analyzing. It's already analyzed. This is just adding markers to the system. Okay, there we go. Now these are the different types of things. It's identified several conditions. I do have a small rotor bar issue, casting void, unbalance or misalignment. It's actually a little bit of unbalance. Some static eccentricity, yep, we knew about that because it's just sitting on a piece of board. And then it does have a bearing defect. So bearing defect, those are in black, running speeds in yellow, things like that. That's all built in here. So if I wanted to see any type of condition, I want to check out the lines and see where they lay. Here's how accurate they get. So this has to do with my static eccentricity. So you can see it's right about here on my line, or yeah, there we are. So going back, so it's identifying that they're all marked. Let's get in here and I'll show you the marks. Let's take a look at the bearings. So here's my bearing markers. Probably going to make those slightly larger. But if I come in here and I see this, this is two bearing conditions. There they are. So drive end inner race, and the opposite drive end inner race. There. And all the way back. And so on and so on. So, and this out here, that means that the drive is set for 2 kilohertz. This is common with drives, especially drives that are not set up properly. Same thing over here. There's my speed, and so on. So as I go through all that, that's pretty much it. Except I can do one more thing. Here, this is my energy stuff. You'll notice if I put in the nameplates, I put in 6,000 operating hours and 14 cents per kilowatt hour. This goes back to all my other stuff. These are all estimations. You'll see estimated on everything because I don't have voltage data. And I click on Analyze, and there we go. So there's my opportunities, and that's it. So that's the software in a nutshell. Basically 2 minutes to collect data, another 3 or 4 minutes to analyze it. That's it. And all at a low cost. This compared to our other product, the Empath, which takes a look at incoming power quality, loose connections, does it all automatically as well. Different price point, but it looks at the incoming power in addition to everything that's driven. And so on. So 2 different levels of systems. This one here, if you're a tech and you just have time for an hour's worth of training, you can be out in the field using this. So if you have any questions, contact us. The information will follow, and let us know. This launches officially next week, and then we start shipping them on November 1st. Thank you very much.